Hey everyone, and welcome back to The Explainer. So, if you're the kind of person who just absolutely loves seeing how things are built from the ground up, you are in for a real treat today. We're going to deconstruct something that, it might look super simple on the surface, but it's actually a literal masterpiece of instructional design. We're looking at Chapter 11 of a primary math book, and it's called How Many Times? We're basically going to peel back the layers and uncover the brilliant, step-by-step cognitive architecture hiding right there inside these colorful pages.
Now, I want you to really think about this for a second. How does a simple, fun trip to the amusement park unlock the foundational secrets of math? Because we aren't just going to sit here and solve primary school math problems today. No way. Instead, we're going to put on our detective hats and uncover a lesson plan that completely seamlessly tricks the brain into learning some pretty advanced concepts through everyday play. All right, let's dive right into this. Section 1, the amusement park visit. So, right off the bat, the chapter doesn't open with some intimidating chalkboard or a bunch of crazy equations. Instead, it starts with a scenario every single child inherently understands. Just look at this vibrant, joyful carousel. Do you notice what's conspicuously missing here? There are absolutely no numbers yet. The authors are deliberately setting up this really comfortable baseline, anchoring the abstract math that's coming up in a totally concrete, relatable reality. Moving on to Section 2, counting by twos, the power of pairs.
Okay, so now that the student is nice and comfortable, the book introduces the most basic form of grouping. We get this awesome little quote. Wow, two of us can sit on the horse. I will sit with my friend. Notice how incredibly brilliant this is. The chapter is using a child's own perspective and dialogue to organically set up a math problem. It's not some strict teacher demanding an answer. It's literally a character making an exciting observation about their own environment. I mean, this is narrative-driven learning at its absolute finest.
So the crucial point is, when we translate that narrative observation into a mathematical framework, we get this. 2 plus 2 plus 2 plus 2. This simple string of addition formally introduces the concept of identical groups to the young learner. It's no longer just counting random scattered objects, it's counting uniform sets. And that right there is the very first, totally subtle step toward much higher level math.
Next up, Section 3, the toy train trios. Now we're moving to the next attraction, and the instructional design here cleverly increases the cognitive load. We're looking at groups of kids in each section of this fun toy train. The grouping size has just officially leveled up, from pairs of twos on the carousel to trios of threes. So the complexity ramps up, sure, but to the kid, it feels like just another fun ride at the park. Let's actually break down the exact mental steps the chapter forces the student to take to solve this new train problem. Okay, first, they visually spot the 3 distinct bogies. Second, they count the kids in just one bogie, which is 3. And third, they add those identical groups together, 3 plus 3 plus 3. It's literally a structured algorithm, but it's completely wrapped up in a colorful cartoon. And boom, here is the incredibly satisfying visual payoff to our toy train equation, 9. By arriving at this number through adding 3 threes, the whole idea of repeated addition is firmly cemented in the viewer's mind. The pattern is officially established. Group size plus group size plus group size. Which brings us to Section 4, the Jalebi math problem. Well, after all those rides, you definitely get hungry. So we're moving from attractions to food, which is a delicious but honestly kind of dangerous way to learn math. The scenario they give us is this. Each plate of jalebi has 3 pieces. They ordered 6 plates of jalebis. Mathematically speaking, things are scaling up really significantly right now. Up until this point, we've dealt with 4 horses, 3 train bogies. Now we are dealing with 6 whole plates. We're taking that newly learned grouping concept and applying it to a completely new, much larger scenario. Now, what's really interesting about this visual design is how it scales up the problem. We see plate 1, we see plate 2. But wait, remember the prompt said there are 6 plates? This layout is intentionally setting kids up to realize something important. Counting every single jalebi one by one across 6 whole plates is about to get really tedious. Let's actually track the math the way the book has taught us so far. Plate 1 is 3. 2 plates is 3 plus 3. By the time we get all the way up to 6 plates, the equation is 3 plus 3 plus 3 plus 3 plus 3 plus 3. Honestly, writing that all out and trying to calculate it, it's super clunky.
And this progression makes it painfully obvious to the learner why math eventually needs a faster, more efficient path than basic repeated counting. The problem itself is actually creating the desire for a much better tool.
And that perfectly sets up Section 5, the hidden lesson. So, that built-in desire for a better mathematical tool brings us to the overarching, frankly brilliant design of Chapter 11. Seeing the teacher step in here, it becomes clear that this entire chapter has been this elaborate, perfectly executed bridge. It bridges the gap between simple adding and multiplying. It is an absolute masterclass in disguised learning. The student is discovering the necessity of multiplication entirely on their own, way before the actual word is ever even introduced to them.
And this brilliantly illustrates the core concept of repeated addition, just adding the same number together multiple times to find a total. That is the secret foundation of multiplication. By making students physically write out 3 plus 3 plus 3 plus 3 plus 3 plus 3, they are intuitively grasping what 6 times 3 actually means out in the real world. They are completely learning multiplication, but without any of the intimidating terminology.
Honestly, just like these bubbles floating effortlessly upwards, Chapter 11 seamlessly builds these cognitive steps using totally everyday scenarios. It floats the learner from basic counting, to pairs, to trios, to these large repetitive groupings, and all the while the kids just think they're taking a fun trip to an amusement park and eating sweets. It is elegant, it's highly structured, and it is just incredibly effective instructional design.
So, to wrap things up, I want to leave you with this final, provocative thought to reflect on today. How many times do we use repeated addition in our daily lives without even noticing it? Seriously, from buying packs of batteries to figuring out seating at a big dinner table, this foundational skill is literally everywhere. Understanding exactly how it's taught helps us so much in appreciating the hidden structure of the world around us. Thank you so much for joining me on this explainer today, and hey, keep looking for the hidden architecture in everything you learn.